how we can make our frequency distribution table using the Sturge rule. The essence of Sturge rule is to enhance uniformity in the calculation of finding the class interval and the class size. Basically, when we have our raw data set, without putting in any frequency distribution table, the raw data set does not make any kind of sense, or it cannot give out any informed decision. And data in its raw form, we cannot easily determine the frequency of the data, or we cannot even make any form of calculation. By using this Sturge rule, it's going to make the frequency distribution table. It's going to make things to be more easier for us. It's going to summarize the data set for us. Suppose that we have a data in its raw form, like 100 data set or 50 or 200. By mere looking at it, the data will be so cumbersome without making any form of sense. We can't determine the kind of frequency or the one that has a lower frequency. Making use of this Sturge rule is going to enhance us to determine the accurate class size and the uniform class interval. In the next slide, we are going to show the raw data set, just as we see here. Given the following data set taken in a region for a period of 35 days of its atmospheric temperature, that is, the atmospheric temperature of a certain region was taken for the period of 35 days. Counting all these data sets, they are all 35 in number. Now we are told to make a frequency distribution table using the Sturge rule, and we have to find the class limit, we have to find the class boundary, we have to find the class mark, which is the mid mark, and we have to determine the frequency, then cumulative frequency. Under here, we have two frequencies to be calculated. Cumulative frequency to be calculated, we have more cumulative frequency and less cumulative frequency. Finally, we have to determine the relative frequency, and the relative frequency is individual frequency all over the total number of the data set, and the sum of the relative frequency is 1. We are still going to see it in the next slide. Now, given this is the formula for the Sturge rule to calculate our frequency distribution table, and the Sturge rule goes as follows. The class interval is equal to range all over 1 plus 3.32 log n. So our data set, we are going to find the logarithm of the data set, and we were told that our initial data set is 35. As you can see, is 35. As you see here, they are all 35. So we are going to find its logarithm. Now, just like I said earlier on, our data set is 35. Then we have to look for the range, and the formula for the range is highest number minus the lowest number. And for this data set, we have our highest number to be 107 and our lowest number to be 72. So deducting 107 from 72, we have 35. Let's show the data now. As you can see, this is the 107 is highest data set here. We have two 107 and we have 72 to be the lowest number among this data set. So we are going to subtract 107 minus 72. It's going to give us the 35. That's how to calculate our range, the range. That is, range is equal to 107 minus 72 giving us 35. Then we are going to calculate our class size. We are going to calculate our class size. So our class size, we are going to calculate it. We are going to determine our class size, that is K is equal to, class size is equal to 1 plus 3.32 log 35. That is, this is the K value. This is the K. These are the expression that we use for our K. That is the class size. That's why we have K is equal to class size is equal to 1.3, 1 plus 3.32 log 35, and the log 35 is given us to be 1.5541, and the answer is 6.1264. We are going to round it up to the nearest whole number, and our k is 6. Then we have to calculate our class interval, that is this range all over k over the class size, that is our k is 35, as you can see here, and our k, the class size, is 6. So we are going to use to determine our class interval. Now we have 35 all over 6, giving us 5.8333, which is approximately 6. So we are going to round it up just like we did for the class size. Furthermore, we should take note of this. To calculate our class mark, we have to add the lower class limit plus the upper class limit divided by 2, that is 72 plus 77 all over 2, giving us 149 all over 2, giving us the answer is 74.5. That is our class mark. So we can do it for all the class sizes that we have in our frequency distribution table, as going to be shown in the next tutorial. Then our class boundary, in order for us to get our class boundary, we have to deduct from this lower class limit, we have to deduct 0.5 from it, and the upper class limit, we have to add 0.5 to it. We are going to see it in the next slide. Then our relative frequency, that is individual frequencies all over the total data set, that's 35, that is 7 all over 35. Maybe another frequency is 2 over 35, another frequency is 5 over 35. So everything is going to be shown in the next slide. Now, given this data set, the one that we have shown previously, the data set that we have shown previously, that is the one with the temperature of that certain region. So we are going to convert this data set into the frequency distribution table. Now we know our lowest value to be 72. Now we know our class interval to be 6 and our class size to be 6. 1, 2, 3, 4, 5, 6. This is our class size. It appears 7 times. Then our class interval, we are going to say is 6 as well. 72, 73, 74, 75, 76, 77. So we are going to count from 72. So giving us 77. Now, since our interval is 6, so the next class interval is 72 plus 6, giving us 78. Then we are going to add 666 to all this value. 6, 84 plus 6, 90, 90 plus 6, 96, 96 plus 6, 102. The same thing will occur to the upper class limit, 83 plus 6, and so on and so forth. Now, in order for us to determine our frequency, we have to tally it. Now, between 72 to 77, we have the tally is 7, as you can see here. So we're going to look at it. 1, the number between 72 to 77, we are going to check it. Well, 1, sorry for the 1, 2, 3, 4, 5, 6, 7. So we are going to tally it here. And in counting our tally, once you count 4, because we have 7, and the next the next number is when you count stroke 1, 2, 3, 4, then you cross it, making 5, then you count the number 1, 2. That's 7. Between 78 to 83, we have 9. So first of all, we are going to count 5, 1, 2, 3, 4, then cross it, making 5. Then we are going to count 1, 2, 3, 4. 5 plus 4 is 9, and so on and so forth. And also, between 90 to 95, we have 8, as you can see here. Between 96 to 101, we have 2. 102 to 107, we have 3. Those are the frequencies. In order for us to, like I said earlier on, that our class boundary, in order to get it, we are going to subtract 0.5 from 72, giving us 71.5. Then we are going to add 0.5 to 77, giving us 77.5. And the same thing, 78 minus 0.5 give us 7.5, and 83 plus 0.5 give us 83.5, and we already know our frequency to be this. Now we are told to calculate, in our question, we are told to calculate the Moore frequency. Now, in order to calculate the Moore frequency, we are going to add, we add from the top to the bottom. Now, 7, we are going to repeat the first 7 here. 7 plus 9, 16. 16 plus 6, 22. 22 plus 8, 30. 30 plus 2, 32. 32 plus 3, 35. It's going to give us the total frequency here. And the less frequency, the way to calculate it, we are going to calculate from the bottom. We are going to add from the bottom to the top. That is the less frequency, 3. We are going to repeat it here. 3 plus 2, 5. 5 plus 8, 13. 13 plus 6, 19. 19 plus 9, 28. 28 plus 7, 35. Now, in order for us to calculate, sorry, I mistakenly pressed something. In order for us to determine our relative frequency, already we have known all this frequency and we know the total number of the frequency to be 35. We are going to say 7, like I shown in the previous slide, that is 7 all over 35 is giving us 0.2. That's how we have this 0.2. Then 35 is 0.25. 6 all over 35 is 0.17. 8 all over 35 is 0.23. 2 all over 35 is 0.06. And 3 all over 35 is going to give us 0.09. And summing, like I said earlier on, summing all the relative frequencies together is going to give us a 0. Once again, the basic rule is that when you sum all the relative frequencies, sorry for the confusion, if you sum every relative frequency together, it's going to give us 1. And again, the more cumulative frequency you are going to add from the top to the bottom, less cumulative frequency you are going to add from the bottom to the top. Then, in order for us to get our frequency, you are going to tally the number from the main data set. Thank you for watching this tutorial. Remember to like, share, and subscribe to my channel. Your subscription is very, very essential for my channel to grow. And again, don't forget to press the notification bell, because anytime I release a video like this, I am going to be the first person to be notified. Remember again to like, share, and subscribe to my channel. Bye.